Hello. So section 5.3 is talked about the fitting linear model to the data. So the table shows below the number of cricket drops in 15 seconds and their temperatures in degrees of Fahrenheit. Plot the data and determine whether the data appearance should be linearity related. If so, find the linear function that fits the data. Okay. So that drops is the frequencies. That means they drop 44 times in 15 seconds. In every 15 seconds. So temperature is in Fahrenheit. Okay, so now let's try to grab that graph without the help of our technology. So here our x coordinate should be the drops in every 15 seconds, and then y coordinate should be temperature. Okay, so the range is, look at the drop, it's 18.5. The biggest number is 14.4. So we can set the range maybe every, starting from 15, and then 20, 25, 13, 35, 40, 45. And then when it comes to temperature, the lowest temperature is 53 or 52. And then the highest is 18.5. So maybe we can do 50, 60, 70, 80. Okay. So I have 14.4 and 18%, which is 18.5, which is around here. And then second one is 13.5 and then 17.5. And then I have 20.4 corresponding to 57. You can do it by yourself. You can pause the video and do it by yourself or fast forward, because I believe that you know how to do plotting, how to plot these two variables. So I have, next one is 13.3, 66. And then 13.1, 68. 13.5, 72. 18.5, 52. 37, 17.3, 26, 53. Okay, so look, this one, do you think this is linearity related? Yes, because as the drop become more frequently, the more drop the temperature goes up. As the temperature and the drop are what? Positive relative, right? So because as the drop goes up, the temperature goes up, right? Or otherwise, I think it's making more sense as the temperature goes up, and then the cracker drops more in every 15 seconds. I think that made more sense. I shouldn't say they drops more and then the temperature goes up. That made no sense. Anyway, so look, do you think this is linearity? Yes, they are, but that could be many lines. I may say, hey, this fits in this line, or sometimes I may say, hey, maybe it fits in this red one. We don't know which one we will say is the best fit one. So how can we do it? Now we need to use technology. So now let me go to the website and type in GeoGebra. So, okay, GeoGebra, and then go to the upper right. There's a waffle icon. I call it waffle, upper right, waffle icon. You click on it and choose GeoGebra Classic. And then on the upper right, there's a sandwich icon. Below the sandwich icon, there's a sandwich icon with a triangle and a circle. We click that one, and then choose the three dots, and then choose spreadsheet, and then type in our data in here. I can swap it here, so I can type in 14.4, 25, 24. You might need to use that for your homework. These tools help you to find the best fit model of the line. Okay, so now the second line, I type in the temperature. Okay, after typing all in, you highlighted these two data. And on the upper right, do you see the second icon with the graph, a histogram graph? You click on it and choose two variable regression analysis. And then there will be a graph. Okay, so after you see the graph, so this is the plot that we just did by our hand. So how can I find the best fit line? By choosing in the lower, there is a regression model that you can choose. Choose linear. Then you will see a red line. Under the red line, they tells you that, hey, this is the model calculated by the computer with the slope 1.1485, and the y-intercept will be 13.1129. So that's how you find the best fit line by using GeoGebra calculator. Okay. So now what is interpolation and extrapolation? So interpolation means when we predict a value that fall within the range of data point that taken, it is called interpolation. When we try to predict the value for points outside the range of the data taken, it is called extrapolation. So now take a look. The difference is interpolation means the data that we took is within the range. Extrapolation means the data we took is outside of the range. That's the difference. Okay, I'm going to give you an example. So if you've already done your exercise before, you will see one called in the previous page. They say, hey, so for the following exercise, consider this scenario. The weight of the newborn baby is 7.5 pounds and the baby gained 1/2 pound a month for its first year. Okay, so think about what would be the model look like. So find the linear function that the model the baby weighs W as the function of the age of the baby in month. So we know that the weight is going to equals to the initial weight, which is when it first born, his weight is 7.5 at 0.5 pounds each month times the month T. So, but this only apply for its first year. So in that case, T, you should have the range from what? The range for T should be from 0, which is its firstborn, till 12 months, right? Because they say that, hey, this only apply for the first year. But now let's consider which one is interpretation. Interpretation means when T is within this range. So the answer that you got interpretation. But if you think about it, can you predict someone that when they were, like, say, 50 years old? So you can keep growing, right? You can keep growing each month by 0.5 pounds, right? That made no sense. So 15 years times 12, that means 600 months. So that means you substitute t equals to 600 when you were 50 years old. So you will weigh what? At 0.5 times 600. So that means you're going to weigh, okay, 307.5 pounds. That would be so heavy, right? So if t, when we choose t equals to 600, outside of the range, this is called extrapolation. Now that makes sense. That means when the data is with a reasonable range, we call it interpolation. So when we use that model, try to predicting something outside of the range, is called extrapolation. Okay, so we're predicting the temperature when the crackers are dropping 13 times in 15 seconds, be interpretation or expectation. Make the prediction and discuss it is reasonable. Okay, 13 times. So 13 times. Is it the cracker chopping 13 times in 15 seconds be interpolation or extrapolation? Now take a look at our graph. If you look at the graph, 13 times, or look at just the data that we connected for the chops. So when we look at the data we're connecting for the chops, we have the lowest frequency would be 18.5, right? And then the highest frequency would be 14.4. So we know that the chops we connect the data is in between 18.5 to 14.4. And the 13 times is within the range, right? Within the range means what? Yes, this is a interpolation. When the data is interpolation, that means we can use it to make prediction. It's going to be reasonable because this is going to fit the model that we just found with GeoGebra. Okay, so second one is, let me erase that. So we're predicting the number of the chopped cracker will make at least 14 degrees be interpolations or extrapolation. Make the prediction and discuss if it is reasonable. Okay. Oh, I forgot to make prediction. You can use the GeoGebra to make the prediction by typing X and Y. I'll show you later in the next example. So when it comes to degree, it's 14 degrees. So now look at the data we connected earlier. So the data, when the temperature data we connected earlier would be what? From 52 to 18.5, right? So 40 is in here, is outside of the range. So that makes it a what? Extrapolation. Because we didn't know. When the temperature below 52 degrees, maybe the model is going to change to something else. It's maybe no longer linear model. Maybe suddenly it drops crazily or become a flat line. No matter how low the temperature it is, it drops the same frequencies. Or, right? Or the other way, like no matter how the temperature drops, the frequency that he chops will be the same. Either way, maybe the model is going to change. We don't know yet. Yes, we can still use the model to predicting how many times he chops in at 14 Fahrenheit degree, but it might not going to be accurate because we didn't connect the data outside of 52. Okay, so it's not going to be reasonable. Okay, so the third one is the gasoline consumption in the US has been increasing steadily. Consumption data from 1994 to 2004 is shown below. Determine if the trend is linear. And if so, find the model for the data. Use the model to predict the consumption in 2008. Okay, so I already type in the data in GeoGebra to save us some time. After you type in the data, again, the left column is going to be the year. The column B, which is the right column, is going to be the consumption in gas, the gasoline consumption. So we highlight the data and click on the icon on upper left and choose two variable regression model. So, okay, before that, we don't know if it's linear or not. So look at, if after the plot, you can tell this is a line, right? So we can just make a safe consumption, say, hey, this is going to be a linear model. And then we can just choose linear model, and then they found you the best fit 9 and the best fit function, which is the slope equals to 2.2091 and the y-intercept equals to 14 to 91. Okay, I'm going to write down here y equals to 2.2019x minus 14 to 91.6091. Okay, so now they ask you to find the model for use the model to predict this consumption in 2008. So all we need to do is just type in 2008 for x, and then they will calculate the y for you, which is equals to 144.25. So that means we can say, hey, in 2008, the consumption of the gasoline is going to be 144. Okay, that's it for the GeoGebra. Let me know if you have more questions.